And I'm going to go ahead, and the chat's open, the participants open. And so what I'm going to do here is I'm going to start with chapters 12 and 13. And then tomorrow we'll do the rest of the chapters, the other 8 chapters, on what I think the 3 most important things to draw your attention to, and a couple tools that'll help you study. Okay, so when we look at each individual chapter, you know, what can happen is that it's like, well, okay, this is only for alcohols, or this is only for that. So what I'm gonna suggest you do is we break it down in the different types of reactions. For example, there's oxidation and reduction reactions, but then we have substitution reactions and elimination reactions, and then we have addition reactions, and we have that special addition reaction that's concerted, like the Diazolar. So the idea is that what we can do is make a list as we go through each chapter and say, okay, oxidants. What are my oxidants? We start with 3 different oxidants in chapter 12, but we add a couple oxidants when we talk in the benzene chapter. We look at those benzylic oxidations and actually oxidizing benzene using ozone. And then when we go to carboxylic acids, we talk a little more about oxidants as well, where we can get specific things to oxidize. So if you start with a list, a set of lists, that one is an oxidants, one is reducing agents, and then substitution reactions, and then elimination reactions. Because in some of the reactions we did before, like in the previous chapter, we substituted a halide for a nucleophile, right? That's one type of substitution reaction. Okay, when we go to benzenes, we're replacing a hydrogen with some other group by our substitution reaction. So that would go under our substitution reactions. And when we go to our acyl halides or our carboxylic acid derivatives, we can substitute something there. Okay, so those also count as substitution reactions. Okay, and most of them are either nucleophilic or electrophilic. So you can divide your reactions into those 2 things. Okay, so that is where I think one way to help organize your thoughts. And when you do that, you don't worry about the exact chemical structure. Look at what the physical change, what the general change is, and what the requirement is. For example, when we did those tables for the chapters 18 and 19, I specifically drew them that they had to have an alpha hydrogen on one of the substrates by adding that CH2, and then the generalized group, the R, was 1 away on that beta carbon. So start building a table, go from chapter to chapter to chapter. Okay, is this an oxidation or reaction, or a substitution, or an elimination, or an addition? You know, what is it? And which table would it fit on? What are the reagents, and what is the requirement? For example, when we talked about reagents in chapter 12, we were doing addition reactions across the carbonyl, okay? But when we talked about carboxylic acids, we could do addition reactions, or we could do substitution reactions. So that would fit on, there would be carboxylic acids on both lists. So that is one way I think that might help bring order into and bring you to understand how similar reagents and similar reactions happen across multiple chapters. Okay? So any questions about that? Okay, so now I'm going to start with what I think are the key, and I think there's 4 of them actually, in the chapter 12, and then I'll go to chapter 13, and then we'll break for the day, and then I'll start with chapter 14 tomorrow. But in the alcohols chapter, we start talking about oxidation and reduction, okay? So the general concept of oxidation is you're creating more bonds to things that aren't hydrogen, more electronegative ions, more oxygen, more nitrogen, et cetera, okay? When we're talking about reductions, we're creating more bonds to hydrogen, okay? So that generalized theme is what we see going on in that. And so we learn about oxidation and reduction. But then we also learned about a couple different reagents to deal with when we talked about oxidation reduction. Okay, we learned 2 reducing agents in chapter 12, the lithium aluminum hydride and the sodium borohydride. Okay, we add new reducing agents in chapters, right? So when we have acyl halides and esters, we add new reagents down there, the diball and the tri-T-butoxylithium reagent. So if you have a list of reducing agents, you're going to start with those two, the lithium aluminum hydride and sodium borohydride from chapter 12, and you're going to add to that in the next chapters here. Okay, so, and do you just need to know that you have two reducing agents? No, you need to know that they're specific about different things. One reduces everything and one only reduces aldehydes and ketones. So knowing their specificity is the key for that system. Okay. And then knowing, as you add to that chapter, knowing that one reagent takes acid chlorides down to aldehydes. Okay. So oxidation reduction, we started with 2 reagents for reduction in that chapter 12. We started with 3 classes of oxidation reagents right there. We had the chromium class, then we had the very softer, the PCC, the chromium, the pyridinium chlorochromate, which takes it from being a strong oxidizer to being a milder oxidizer. And so we had a specific reaction associated with that, the making of an aldehyde. But we also have potassium permanganate, which is our 3rd class of oxidant in our chapter 12. So we have reducing agents and what they do, our oxidizing agents and what they do, and the selectivity between them. That's the next most important thing in chapter 12. Okay. Now, the next thing we learned in chapter 12 was we were going to learn addition reactions across carbonyls. Okay. And so different nucleophiles can do that, and we introduced a specifically strong nucleophile, specifically the Grignard reagent, the organolithium reagent, and the Gilman reagent, or the copper lithium reagent. Okay. All of these created these strong carbon anions, which were strong nucleophiles, and all of them do addition reactions across that carbonyl compound. Okay. So in all of those addition reactions, they're all, basically the same thing, where we create an anion on that carbon, and we either get addition products across carbonyls, or the one other reaction we learned there is we can ring open epoxies, that 3-membered ring with the oxygen on it. We can ring open that to generate alcohols. Okay. Now, in the end of this section right here of this addition products, we learned that we can make primary alcohols, secondary alcohols, or tertiary alcohols using Grignard reagents if we attack the correct substrates. Okay. So if you have a Grignard reagent, you know that you have to, if you want a primary alcohol, you have to attack formaldehyde, and that's the only way to do it. If you want a secondary alcohol, you attack an aldehyde, and that's the way to do it. If you want a tertiary alcohol, you attack a ketone. Okay, so that is showing you that your addition reaction can control their substrate. What you start with controls what your product is. Okay. So the last thing we learned in that chapter was that these Grignard reagents are sensitive to things that have acidic hydrogens. Okay. And so we learned how to protect alcohols that have acidic hydrogens by making them into a silyl ether group, a protecting group. And so that's the last thing we learned in the chapter 12 that I think is, something that you need to draw your attention to. All right, questions on the top 4 things on chapter 12. Oxidation reduction and the reagents associated with that, addition reactions on carbonyl compounds and the ring opening reaction in ethers, and what reagents you would use and what their products would be, and then protection of the alcohol to be able to use it to do substitution reactions on carbonyl compounds. Okay, so in our last 20 minutes, I want to go ahead and do chapter 13. Now, chapter 13 was our conjugated unsaturated systems, meaning that we started in the alkenes chapter with just having one double bond and learned how it reacted. We can do addition reactions across them, etc. And then learned how that if they're in conjugation with each other, number one, what does that mean? We have 4 different types of conjugation, of being able to show that system. And we learned that specifically dienes have a different reaction than they have. I'm sorry, we have 4 different kinds of resonance. That's what I meant to say. We have our conjugated pi bonds. We have our adjacent pi bonds to something with a lone pair. We have a pi bond next to something that has a charge or a radical, like an anion or a cation. And then we, of course, have these polarized bonds like we have with a carbonyl, okay? So we learned about resonance and how that changes our reaction, shows us why dienes react the way they do, okay? So the next most important thing we learned about was that when we have a conjugated diene, we have an opportunity for 1,2 addition or 1,4 addition. And we learned why we can do that 1,2 and 1,4 addition because of the resonance structure of our intermediate, okay? So the stronger the nucleophile, the more likely you are to get 1,2. The weaker the nucleophile, the more likely you are to get 1,4, okay? And you have a thermodynamic versus kinetic balance to take into account there. Okay. So let's see, the third most important thing was all the different reactions of dienes, right? We had 1,2 and 1,4, and how you can like suggest to the molecule to do one versus the other. That's the thermodynamic versus kinetic addition reactions there. And then learning that what kind of controls one versus the other. There's a proximity effect there. If it's a strong nucleophile, it just wants to react and be done. If it's a weak nucleophile, it can wait around. So how that affects the product ratio with that. Okay. And then the last thing I think we need to learn in the conjugated diene reaction is that new reaction type that we hadn't done before, and that's the concerted reaction. That's where everything kind of gets prearranged, and then all of a sudden, 3 pairs of electrons move, and we generate our 6-membered ring. And so that gives us our Diels-Alder reaction. And we learned that this is, still slightly, electrophilic, nucleophilic, because our dienes, we want to be electron rich. And our dienophile, or alkene that comes to it, we want it to be electron poor. Okay, so there are some electronic factors, and that gives you that, get them in the right position, and then they form that reaction. So it's a it involves electrophile, nucleophile, but it also involves all the electrons moving all at the same time. And then, of course, we have rules associated with the Diels-Alder reaction. You want an electron-rich diene, you want an electron-poor dienophile. You want to make sure that they stack up correctly so you get the correct endo versus exo formation product. So those are the 4 most important things in chapter 13. All right, questions? If we don't have any questions, I can go to chapter 14 as the 4 most important things in chapter 14. I'm not muted. Thumbs up. All right. Okay, I'm going to move on to chapter 14. All right. So in 14, we started learning about aromaticity. Okay. We learned about the benzene reactions in chapter 15, but we learned about what aromaticity was. And there are 4 rules of aromaticity. It has to be in a ring. It has to be the correct number of electrons. It has to be p orbitals, and it has to be completely coplanar. Okay, so the rule for the number of electrons is 4n plus 2, where n can be any number from 0 to 100. Okay, and if it is an even number of electron pairs, that's anti-aromatic. An odd number of electron pairs is aromatic. Okay, so it's all about the aromaticity. Now, then we had to figure out which electrons were contributing to the aromaticity and which electrons were outside of that aromaticity. Okay. And when we talked in chapter 20, we learned that changes the base strength of that lone pair as to whether it's being consumed in making the material aromatic, or if it's completely outside of the aromatic ring, and therefore it increases its basicity. Okay. So let's see, we also learned a lot about, actually I'm gonna do the nomenclature separate. Let's see, we learned aromaticity, we learned different molecules, we learned why. Let's see, we did a little, yeah, and then we did a little spectroscopy. Okay, so let me back up and remind you that you have a sheet on Canvas that is all of the rules of nomenclature. Okay, on that sheet you have primary, secondary, and tertiary alcohol, primary, secondary, tertiary amine, the priority of the group, which group takes priority when you name the compound. Carboxylic acids are typically the highest priority, and every other substituent moves down from that. And like we talked about in our most recent amines chapter, that is very low priority group. If you have anything else almost on there, it's going to be named for the other thing. So the general rules of nomenclature. In chapter 14, we learned the specific rules for benzene nomenclature. We have orthometa-para, 1,2 substitution, 1,3 substitution, 1,4 substitution. We learned that the highest level functional group changes the name of the benzene ring, okay? And we learned some common names, toluene, styrene, aniline. There are several common names that are learned in that chapter 14 that are for the benzene compounds. And there are even some common names for disubstituted things, like xylene and toluidine, and the dicarboxylic acids of phthalic acid and isophthalic acid and terephthalic acid. Start making lists that have your reagents and which chapters you found them in, right? Group them into oxidants, reducing agents, substitution reactions, elimination reactions. You know, start grouping them and starting to look at the similarities between them. Most of our substitution reactions are nucleophilic, but we do have some electrophilic attacks. So make sure those are separated in your head. Okay. Well, I have time to go over chapter 15 too, and if nobody has any questions. So the great thing about chapter 15, which is the benzene reaction ones, is that the majority of the reactions in there are all the same mechanism. Electrophilic aromatic substitution. We kick out a hydrogen and add some group. We only have 3 steps in that mechanism. Generate something with a positive charge, have the benzene reach out and grab it, and then eject out a positively charged proton to re-aromatize the ring. Okay, and we can put, you know, halogens on there, and we can do, we can put bromines and chlorines on there, and we can put sulfonic acid groups, and we can put nitro groups, and we can put acyl groups, and we can put alkyl groups on there. We just have to pick our Lewis acid catalyst to generate our cation to be attacked by our benzene. Now, remember in chapter 15, we only learned how to put bromine and chlorine on there. In chapter 20, we learned how to put iodine and fluorine on by going with the nucleophilic aromatic substitution of creating a diazonium compound and then having that be the one displaced. We're not displacing hydrogen in chapter 20. We're replacing a diazonium, or a nitrogen is removed, and we are allowed to use a nucleophilic attack on the benzene. Okay, so In chapter 15, it's all electrophilic attack, but we learn we can use a nucleophilic attack if we prepare the diazonium compound first. So that would be another thing to kind of add to your list in making sure you compare and contrast. Okay, so I think, and we learned that, oh, we actually added a couple oxidation materials in chapter 15 as well that we would add to our oxidation. We still figured out we can do that benzylic oxidation using permanganate, and so we can take any substituted part on a benzene that has a benzylic hydrogen, and you can oxidize that down to a carboxylic acid, right, using permanganate and that type of reagent. However, you learned that you can take any alkyl group and oxidize off the benzene ring or an alkene by using ozone. It'll attack the double bond. And so we have two new oxidants to think about when we're looking at that, adding to our list of oxidants that we find, and that's found in chapter 15. Okay, I'm going to stop there and answer questions for anybody who's left, and then we'll do this again. I'm going to actually maybe I'll get a list together of the top 3 topics or top 3 or 4 topics that for each of these chapters, and I'll post that onto Tracks. Okay. So I actually used to teach a version of this course, and I only hit the top 3 in the lecture, but nobody else would go look at the other videos. So I stopped doing that, and I want to do everything first and then draw your attention to the top 3 after we've done it. So to make sure you've heard the whole story and then figure out, I need to know at least these 3 things, and then I can figure everything else around it. Okay. Okay, great. All right, so I'm going to stop recording, and then I will post this as soon as it's done.